Welcome back to The Explainer. Today, we are breaking down what is honestly one of the most massive shifts in human history. We're looking at a journey that stretches all the way from the mechanical logic of ancient Babylon right up to the highly advanced silicon-based intelligence powering our world today. And look, this isn't just some conceptual exercise. As we dive into Day 3 of the Deconstructing Industry Reality Check series, we're unpacking the reality of a rapidly approaching future. It's a future completely defined by autonomy, massive infrastructure, and an entirely new way we interact with machines. So we're going to clearly map out exactly where we've been, where we're heading by 2026, and the incredible scale of what it's actually taking to get there.
$6 trillion. That is the staggering truth about the future of tech. I really want you to use this massive figure as an anchor in your mind for the sheer scale of the frontier we're about to explore. Just to put that into perspective, if this tech frontier were a country, it would literally be the third largest economy in the world. We aren't just talking about a few new apps or, a slight upgrade to your smartphone. A $6 trillion shift implies a fundamental rewiring of the global economy. It means heavy physical infrastructure, completely new security protocols, and an evolution of intelligence that demands unprecedented global investment. So keep that $6 trillion in mind as we look at what exactly is being built.
To map out this $6 trillion shift, we're going to hit 5 key areas today. First, the evolution of intelligence. Second, the 2026 tech landscape. Third, fueling the transformation. Fourth, global adoption strategies. And finally, opportunities and challenges.
All right, let's jump right into Section 1, the evolution of intelligence, and contextualizing this massive shift.
The story of computing is just relentless. It didn't start with the internet, right? It started with mechanical calculators back in the 17th century. And fascinatingly, those early machines were entirely physical. We're talking intricate configurations of brass gears and dials designed by minds like Pascal and Leibniz just to do basic arithmetic. From those brass gears, we leap forward to the 1940s, where massive, room-sized vacuum tube machines achieved the incredible mathematical breakthroughs required for wartime code breaking. Then, the pace accelerates exponentially with the invention of the integrated circuit in 1959. Suddenly, computing became microscopic, it became scalable, and the foundation for modern society was poured. Over time, we evolved from physical gears to vacuum tubes to the software-driven silicon chips that shape nearly every industry today. But now, we have arrived at an entirely new era: AI and intent-driven systems. This isn't just an upgrade. It is a fundamental shift in how humans and machines interact.
Think about it this way. Historically, computing was all about writing code. It was about manual computation and explicit line-by-line instruction. If you wanted a system to perform a task, you had to steer it through every single turn. Imagine being in the passenger seat of a car and having to tell the driver exactly when to hit the gas, exactly when to brake, and exactly how many degrees to turn the steering wheel. That is writing code. Today, the paradigm has shifted entirely to expressing intent. We are moving into an era where intelligent systems can interpret our goals and execute really complex tasks with minimal human intervention. Now it's like you just get in the car and state your destination. The system calculates the route, avoids the traffic, and gets you there autonomously. Moving right along to Section 2, the 2026 tech landscape. Let's deconstruct this frontier.
Right at the forefront of this new landscape is physical AI. This is where artificial intelligence literally breaks out of the digital screen and actively moves into tangible reality. Physical AI enables machines and robotics to operate with incredible autonomy right within industrial and operational environments. Instead of a factory robot endlessly repeating one pre-programmed motion, imagine a robotic arm that can dynamically adjust its grip based on what it's picking up. It inherently knows to handle a delicate egg totally differently than a heavy steel block. It perceives its physical surroundings, understands the operational intent, and takes physical action without a human having to write new code for every single variable. It's wild.
Meanwhile, back in the digital realm, we've got the second pillar of this frontier: self-managing software. Think of this kind of like a digital immune system. Human bodies don't require conscious thought to fight off a common cold, right? Our white blood cells just automatically detect the threat and attack. Well, self-managing software does the exact same thing for complex computer networks. Through automated monitoring, issue detection, and self-healing capabilities, these systems actively reduce their reliance on human engineers. If a massive server network detects a flaw or an impending crash, it initiates a self-healing process, rerouting traffic and patching the issue entirely autonomously. The operational resilience this provides is absolutely staggering.
Now, with systems acting this autonomously, the underlying data they run on becomes arguably the most critical asset on Earth. Enter the sovereign cloud. This is infrastructure specifically designed to protect that asset. It ensures that information remains strictly within defined geographic and regulatory boundaries to strengthen data control. Think of it as establishing digital embassies. In a hyper-connected world where a server physically sits and whose national laws govern that specific piece of land matters more than ever before. Data sovereignty basically ensures that nations and corporations maintain absolute authority over their own intelligence.
Which brings us to Section 3. Fueling the transformation, focusing on the infrastructure. To actually support this massive shift, unprecedented stakes are being placed in large-scale computing infrastructure. Remember that $6 trillion figure? It's not just theoretical software. It's literally pouring concrete, laying millions of miles of fiber optics, and building immense physical data centers required to process heavy AI workloads. But, with that sheer scale comes the absolute necessity for defense. Because these AI systems operate and heal autonomously, human reaction times are now way too slow to protect them. So we're seeing massive investments in cybersecurity systems that operate at machine speed, meaning AI fighting off AI attacks in milliseconds. And looking slightly further over the horizon, we are actively laying the foundations for quantum-resistant connectivity and encryption, preparing for a future where our current traditional security models are going to be completely obsolete. All right, Section 4. Global adoption strategies and worldwide implementation.
Technology adoption is never a one-size-fits-all kind of deal, but we are seeing a really clear, logical global path. Step 1 starts with the immediate integration of AI to reduce repetitive work, freeing up human capital for higher-level thinking and creativity. Step 2 sees entire economies reshaping access and scale from the ground up by building robust digital public infrastructure. Think unified national payment networks or seamless digital identity systems. Step 3 recognizes the immense power of these intent-driven models, prompting nations and industries to implement strict governance frameworks, ensuring AI is deployed securely and responsibly. And finally, Step 4 represents a maturation of cloud strategy worldwide. Moving to the cloud is no longer just some simple IT migration checklist. It is a strategic, foundational shift focused entirely on long-term efficiency and sustained value creation across every single sector.
And that leads us to our final act, Section 5, Opportunities and Challenges, the Global Reality.
Look, these digital opportunities are absolutely incredible. Faster development cycles, smarter automation through physical AI, and highly resilient, self-healing digital systems. But they carry a massive physical anchor. The digital dreams we are actively chasing require us to confront steeply rising energy consumption. We are talking about data centers that require entire gigawatts of power and advanced liquid cooling systems just to keep the servers from melting down. This creates immense physical infrastructure demand, forcing a complete reimagining of our global supply chains and power grids. Coupled with rapidly evolving cyber risks, it becomes incredibly clear that our digital advancement is entirely bottlenecked by our physical and operational limits.
So it really all comes down to this one core question. As technology evolves at remarkable speed, moving from rigid code to autonomous intent, can our physical infrastructure and energy grids actually keep up with our digital ambitions? It's the central tension of this entire tech frontier. We clearly have the digital intent, but the physical capacity remains the ultimate challenge. I want you to keep that provocative reality in mind as we wrap up today's analysis. Thank you so much for joining me for Day 3 of the Deconstructing Industry Reality Check series. I look forward to seeing you tomorrow for Day 4, where we will be deconstructing FMCG. Take care.